So in our last video, we saw how the merge sort will work. Today we'll see how the quick sort will. Quick sort is also one of the sorting technique which will work on the divide and conquer method. Here also array will be partitioned in such a way that one element will take from array and make it as a pivot. In every partition, the array will be in such a way that the pivot element or key element will be in the center. Will we have two array such that one array all the elements are less than the pivot element and another array subarrays all the elements are greater than that pivot element. And this two array, just whatever the pivot element we have taken, that will be in its position. It will get our correct position, and rest again two other two arrays subarrays will be again the same method will be implemented on that, and partition, we will partition that subarray. So let us see how that works with an example. We'll take one array of size of 5. So our array is our array is 1, 2, 3, 4, 5, 6. Sorry, 6. 0, 1, 2, 3, 4, 5, and 6. So first element is 8, second element is 7, third element is 11, fourth element is 6, 10, 3, and 2. So what we will do now, this is our main problem. So now we are dividing this array into two parts and partitioning the array using the technique, that is partitioning technique. After the partitioning technique, what happens? So we will take first element of the array as a pivot element or a key element, key or pivot element. So now 8 is our pivot element. So now array is divided in such a way that all the elements less than, so say 1, 2, 3, all the elements less than pivot element will be in the left side, and all the elements greater than pivot element will be in the right side. See, our pivot element is 8. So 7 is less than 8. So 7. Next 11 is not. 6 is less than 8. So 6. And 3 is less than 8. 3. 2 is also less than 8. So 2. Now here what? 8. Now 11 and 10. See, greater than pivot element is 11 and 10. So these two will be separate array, and these four are again will be separate array. Again, so now 8 is in its correct position. We need not to sort this. So again, this part and this part, this subarray and this subarray will be again partitioned. See, again, now we will take 7 as a pivot element. Now what we will do? Now here 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6. See, now 7 is our key. Key is equal to 7. Now the elements less than the key will be in the left side. So 6. Okay. 3, 2, and 7. Okay. This is now, and after that last, then no, all the less than element and equal to element are written on the left side. So right side there are no elements. So now this element is now 11 is the key element. So the element lesser than 11 will come to the left side, 10, and the remaining is 11. So this is also now sorted. So now what happens? See again. This again we can partition it. How we will partition? See, 6 is now key. Now what happens? 1, 2. So and it is here only. Okay. 0, 1, 2, 3, 4, 5, 6. See, now this is our array need to be partitioned. Already this array now sorted. See, again what happens now? 6 is our key. 3 is less than 6. So 3. 2 is less than 6. Now 6 is, 7 is greater than 6. So it will come here. This is the 6. 6. Now 6 has got now separate. And this is also have got now separated. See. Now these two need to be sorted. So what happens now? The remaining will be same. 8, 10, 11, 4, 6. 0, 1, 2, 3, 4, 5, 6. Next see here. Our pivot element is 3. So all the element less than 3 is kept 2 left side and remaining is 3. 3 is equal to the next. So remaining is same. 6, 7, 8, 10, 11. C. 0, 1, 2, 3, 4, 5, 6. Now the array is sorted. What we have done? In every step we have taken one pivot element and we have compared. We have compared it with what? Elements. Next, whatever the elements which is lesser than that pivot element, we have kept it in left side, and elements greater than that pivot element or keyword, we have kept it in right side. So we will get the proper position for the pivot element, and it is divided. Left to the pivot element will be one array, and right to the pivot element will be one sub array. So again the separated array will be partitioned again with the same method. So repeatedly when partitioning the recursively partitioning that sub arrays, will get the sorted array. So how we will do it in using a code, we will see. What is up now? Our function is partition. Partition array we have to pass lower bound and upper bound. So our lower bound is this and our upper bound is this. Okay, now see what we have taken that. Now we will take the first element of the array as a key element. So key is equal to A of L. Why A of L? L is the lower bound, which is the first element in the array. So A of L. L is what? Here 0 now, pointing to 0. So, and again we will take one more variable as start and one more variable as end. So start is equal to L and end is equal to upper bound. Okay. We will take one condition. While start is less than end. When start is less than end, again we will take while A of start is less than or equal to key. You have after key, what we have to do? Start plus plus. So again, while a of end is greater than key, we have to end minus minus, decrement the end. So next, if start is less than end, if start is less than end, swap a of start comma a of end. Okay, this is one function. This while loop closes here, and now swap a of L comma a of end, a of end. So again, what we have to do? Return end. See there. So we'll see now. Now 8. Now 8 is our key element. Now our key is 8. So what we will do? Now key is 8 now. We will compare. Now start is pointing to index 0. So that is here. Now we will check a of start is what? Less than or equal to key. Less than or equal to key. Before that we'll check start is less than or equal to end. Yes, start is less than end only, because start is 0 and end is equal to 6. Start is equal to 0. Okay, see, start is less than or equal to key. We will check whether start is, what is the value of a of start? A of start is 8. 8 is less than or equal to 8 because key is 8. Okay, the condition is true. Yes, the condition is true. If the condition is true, what we have to do? We have to increment the start. What we have to do? We have to increment the start. So now the start is 1. So what happens? Now the start is pointing where? Now the start will point here. Okay. Again, see. Again, what we have to do? Again, we have to go back because while condition is still true, we have to reiterate the while loop until the condition is false. So again, go where? Start. A of start is now, start is pointing here now. So A of start is 7. Key is 8 only. So whether 7 is less than or equal to 8? Yes. So what happens? 7 is less than or equal to 8. So what we have to do? We have to increment the start. So start is now 2 and start is now pointing here. Okay. See. Now start value is 2. So A of 2 is what? 11. 11 is less than or equal to 8? No. Condition is failed here. So we have to come out of while loop. And again we have to check whether the A of end. A of end is what? A of end is, that is, A of end is greater than key. We have to check. A of end is, end value is 6. So A of 6 is what? 2. 2 is greater than key. Key is what? 8. The condition false. So here this condition false. This now we have to what have to do? We have to come to while loop will not execute because condition is failed. Now we have to come to this statement. Again we have to check now. What start is less than end. Now our start is what? Start is 2 and end is start is 2 and end is 6. So start is less than 6. We have to check. Start is 2, end is 6. So 2 is less than 6. So our condition is true. What we have to do? We have to swap A of start and A of end. So our array will be now what? 8, 7. So 11 is swapping. What we have to swap? A of start and A of end. Start is here. So A of start should go here, A of end should come. So 2 will come here. 6, 10, 3 and 11. And now start is, where is our start now? Our start is still here. Start and end is still there only. Okay, again see here. Still this loop is going on. Again we have to check. So what is the value of start? 2. And what is the value of end? 6. So we have to check whether start is less than end. Yes, it is less than end. So again, while A of start is okay. Now we have to check A of start is less than or equal to key. A of start is what? A of start is pointing at what position? A of 2. A of 2 is now 2. 2 is less than or equal to it? Yes, condition is 2. So we have to increment the start. And now start value is 3 and we will start. Okay. Next. Again. This condition again. A of start is less than or equal to key. Now start is 3. A of 3 is 1, 3, 4, 5, 6. A of 3 is 6. So 6 is less than key, that is 8. 6 is less than 8. So condition is true. So now start will be incremented. That is 4. So our start is here. Okay. Now see here. Again. Now A of start is now A of 4. A of 4 is what? 10. 10 is less than or equal to 8? No. Condition failed. So it will come to this loop. Now we have to check A of end is greater than key. What is A of end? It is 2. Sorry, A of end is now what? Here 11. A of 6 is 11. So 11 is greater than 8. The condition is true. What we have to do? We have to decrement the end. So decrement means 1 minus 5. So end will now point here. Okay. Again, this condition is still true. So again the loop will be continued. While A of end, now end is 5. A of 5 is what? 3. 3 is greater than 8. 3 is greater than 8. No, the condition is false. So it will come out of the loop. So now our start is 4, end is 5. So this condition is checked. Now this condition is true because start is 4, end is 5. So start is less than end. So this condition will executed. So what is that? Swap A of start and A of end. Where is our A of start now? 10 and A of end is 3. So this both should be swapped. So now our new array will be 8, 7, 2, 6, comma 6. You have to swap this 3, next 10, comma 11. Okay, what happened now? So now our start is here and end is here. 0, 1, 2, 3, 4, 5, 6. Okay, again see this loop, again it will go to while loop. Now start is what? 4, 5 is, end is 5. So this condition is true. Again we have to check a of start is less than or equal to c. A of start is what? A of start is A of 4. A of 4 is what? 3. So 3 is less than or equal to 8. So what we have to do? We have to increment the start. So 5 and here now start is also here only. Start and end are both pointing to the same position. Okay. Next step. Again, while A of start are less than or equal to key, what is A of start? What is A of start now? A of start is A of start is 5. So A of 5 is 10. Less than or equal to 8? No. The condition is failed here. So condition is failed. It will come out of the loop. We will check this while A of n. A of n is what? A of 5. That is A of n is now 10. 10 is greater than or equal to 8? Yes, condition is true. So condition is true. What happens now? N minus minus. So n will be 4 and now the pointer will be, n will be here. Okay. See this. Again, while A of n, A of 3. A of 3 is what? Sorry, A of 4, n is 4 now. A of 4 is what? Okay, here. A of 4 is 3, sorry. Is 3. A of 4 is 3. 3 is greater than 8? No. The condition is failed, so it will come out of the loop. It will check now. If start is less than n, start is 5, end is 4. This condition also fails. Now it will come out of the loop and it will go for the loop here. Again it will check. Start is less than n. Start is 5 and end is 4. The condition failed. So it will come out of the loop and execute this. What? Swap A of L. A of L is what? L is what? L value is 0. So A of L is now 8. 8 and N. A of N. What is that? 3. We have to swap 8 and 3. So now our next array will be 3, 7, 2, 6, here 8 because we swapped 3 and 8, 10, 11. Okay, see here, this is the first one partition is over. So after the first partition, what we are seeing, this is our key element. What? 8. We can observe here. See, all the element left to the key, right to the key element, left to the key element is lesser than that key element. The elements in the right to the left to the key, right to the key element is always is greater than what? This key element. See. So we have partitioned the array. So again on this array, only on this array, we will recursively call this partition function. So how we will do that? We will see in quicksort code. You understand how the partition will be done. So similarly, again in next partition, only this code will be executed on this array and this array separately. Okay, I will show that in code now. This is function for quick sort. In quick sort, what we will do? We will pass one array, lower bound, upper bound. Okay. So in this function, first we will check if L is less than U. Okay. Then location. So in this function we will return end. So return end is what? Now last where was our end was pointing? Here the end was pointing. Yes, here the end was pointing at fourth position end. So this will return and we will store it where location is equal to partition A, comma L, comma U. So this function return end. So this location will store this end. That is 4. Okay. Next, you will see. Again, what we will do? We will do quick sort. A, comma location, not location, sorry. L, comma location. And again we will call quick sort A, comma location plus 1, comma U. See here. What the quick sort will do? It will check for the lower bound and upper bound. If our lower bound is lesser than upper bound. Then we will call partition. We will store the location. We will store the whatever the partition function return the value in location, and we will recursively call the quick sort. What this quick sort will do? Again, we will check for lower bound and upper bound. But this time in quick sort, what it is? Our lower bound is L and upper bound is location. Where we will get the location? Location will get that from here. So here twice we have called the quick sort. Why? The array is divided in two parts. Last step we have seen. See here. See, this is our end position. End position is the location. End is stored in location because this partition will send the whatever is returned here. End is returned and it is stored in location. So location is what? 4. So from 0 to 4. See, A array is passed and L is our lower bound 0. Upper bound is 4 because location. Till here one array and again quick sort is called on array A, location plus 1. Location plus 1 means 4 plus 1 5. 5 to end upper bound U6. This is one array. In the last step we just saw. Till that I will show. Okay, in last step what happened? 8 was our key element and rest 21 7 11 not 11 7 2 3 6 and 11 10 like this was our something like our array. See, this was our what? End. This was our end. So this was our end. See, 0 1 2 3 4. So quick sort is called on first. The quick sort is called on full array. A is our array. L to U. Upper bound 0 to 6. So called. So this function will be called. Again here partition is called. Partition what it will return? It will return end. End is what? Our here 4. 4 is our end. Again with that value we will call again this quick sort. Again recursively quick sort will be called. Again AL location. Location is what? Till this array. Quicksort is applied on till this array. And location plus 1 to you. Here to here 100. Again this quicksort will call again recursive will call the quicksort. Whichever the party end will send here. Again next. In each step the array will be divided. So this quicksort will be recursively called again and again until the array is sorted. Okay. This is what quicksort. What we have done here in quicksort? We have taken one pivot element and we compared with the element, and we have taken two variables. What? Start and end. What we are doing? First, we are checking the start value, a of start value with the key element. If the a of start is less than key, what we are doing? We are incrementing the start until the condition is failed. Which condition? A of start is less than equal to key or is failed. That is, A of start should, if A of start is greater than key, then we will stop that increment. And we will go for next from last array, last element of the array. What we are doing? We are comparing the end, A of end with the key. If A of end is greater, then we are decrementing the end value one by one until A of end is less than key. Okay. Then what we will do? We will check for start is less than end. If start is less than end and we have no chance to increment start and decrement end, then we will swap both the value A of start and A of end. We will do. Once the A of start and end is crossed, what we will do? We will copy the key element, or where is the key element? Start of the element. That element will start with the end, A of end. This is continuously done. Okay, I hope you understood. Thank you.